1/12.
Yes.
Excellent. Okay. So I did actually, I had to go another route. I did find some subtraction problems here. Let's see if I can. So let me make one up for you here. Let's say it's 5/6 minus 3/4. Okay. So what would you do to make the bottoms the same? What would you do to make a common denominator?
I would 6 times 4.
Times 4, and then the 5 times 4.
And
Good.
then after 3 times 6 and 4 times 6.
Okay, 3 times 6, 4 times 6. Good. Okay,
And-
so give me the new fractions.
Okay. Wait. So okay, the new fractions are 20/21.
24.
Oh, sorry, 24, sorry. And then 18/24.
Good. So this becomes
2/24.
24. Yeah. Now the thing is that you can actually divide both of these by 2. What does that become?
2 divided by 2 is 1. And
Okay.
then after 24 divided by 2, 24 divided by 12.
Just 12. Good. Okay, so let me give you one here to try on your own. Let's go 4/5 minus 2/3.
I try this one on my own, right?
Yes, exactly.
Okay. So if I can divide, I can, right?
Yes, if you can, your final answer. I'm not sure if this one does or not.
So can I divide it more by 2, or just I can only divide it by 2?
Other numbers, but what did you get here as your
12/15
okay minus?
minus 10/15.
Okay, so that's 2/15, and the only number that goes into 2 is 1 and 2. So you only have to try 2. If 2 doesn't work, then you're okay. You can
Okay.
stop there. All right. Is that good?
Yes.
Okay, so I noticed, and this is from lesson 3.10. There's a bunch of problems that I guess have not been done, so we might as well try a few of these. First one here is 4/5 minus 3/10. Okay.
Okay.
So what you first look for is does the 5 go into the 10? Does the 5 go into the 10?
Yes.
Yes. What do you multiply 5 by to get 10?
5 times 2.
Times 2. Good. So you're going to multiply the top and the bottom by 2. So what does the top become? What does the bottom become?
The top becomes 8. over 10.
Minus 3 over 10. Okay, now what does this equal?
5 over 10.
5 over 10. Now, both of these numbers can be divided by 5. Okay, so what is 5 divided by
1 over
5?
5.
What 10 divided by 5 is
Oh,
not
10.
5, it
2.
is 2. Good, so that's your final answer on that one. I think we've already done this one, but might as well have you do it again. So let's do 3/4 minus 2/3. Could you try this one on your own, please?
Okay. Do I have to multiply them too?
Multiply them both by the bottom.
Okay.
They're unlike denominators.
3, 5, 4, 9, 9, 12, 8, 1 over 12.
Yes, it's 1 over 12. Very good. All right, next question here. Again, I'm going through lesson 3.10, so you might find these useful. Okay, here's a new problem for us to work on. So you have to decide when the denominators are different if you need to multiply them both or just one of them. So in this problem, what you ask yourself is can you turn the smaller number into the larger? Can you turn a 4 into an 8 by multiplying?
Yes.
Yeah, you're going to multiply by 2. So you take the 4 and multiply it by 2. And the 1 by 2 as well. So see if you can work it out from here, please.
Do I give you my final answer or just the
Yeah, go ahead and subtract and let me know what you come up with.
Mm-hmm. 3 over 8.
That is correct. Okay, very good. All right, so now let's look at another problem here. It's the same thing. You have to decide if you can make the smaller number into the larger number.
Yes.
Yes, you can. What do you multiply the 3 by?
3 times 2.
And 2 times 2. Okay, so you're going to write your new fraction. What does this equal when you subtract?
It equals 3 over 6.
Okay, now can you simplify this? Because there's a number that goes into both the top and the bottom. Or what numbers go into the top? What numbers divide 3?
2.
2 does not go into 3.
Uh,
What numbers go into 3?
1.
1 always works, but it always is itself. 3 goes into 3.
Oh.
You can divide each of these by 3. Okay, so what is 3 divided by 3?
3 divided by 3 is 1.
Okay, and 6 divided by 3.
3.
Try again. Six divided by 3.
6.
6 divided by 3. How many times does 3 go into 6?
3 going to 6. Two.
Yes. Good. Okay, so here is a new problem for us to look at. Subtract 5/8 minus 7 over 12. So the denominators are different, and 8 doesn't go into 12. There's no way to go from 8 to 12. You multiply by 1, that's 8. Multiply 8 by 2, that's 16. So we could multiply the 5 and the 8 by the 12 and the 7 and the 12 by the 8, but that's going to make the numbers pretty large. Okay, so the other option is to find the least common multiple between 8 and 12. So you start writing multiples of 8. So help me out here, Zoe. What is the next multiple of 8? What is 8 times 2?
8 times 2 is 16.
How about 8 times 3?
8 times 3 is 24.
Okay, and what's 12 times 2?
32.
Try again. Times 2.
Oh, 12 times 2. 24.
24. Now, do you see how these match?
Yeah.
So we want a 24 on the bottom of each. What do you multiply 8 by to get 24?
Multiply by 3.
By 3. And you see how it's the third number in the list?
Yeah.
So you're going to multiply the 5 by 3. What is 5 times 3?
15.
15. How do you go from 12 to 24? What do you multiply by?
12 to 24. And multiply by 2.
Okay. So now what do you multiply the 7 by?
7 by 2.
Yes. So that's 14. What is the result of this?
1 over 24.
1 over 24. Very good. So in some ways, the hardest part is just finding the least common multiple. So we'll do that again in this new problem here. Okay, so we want to find the least common multiple between 12 and 16. So can you give me the first multiple of 12?
24.
Okay, and the next one?
36.
Okay, and then 48 is the next one.
60, 72.
32. What's the next multiple after over 32?
32.
You're adding 16 each time, or you're multiplying by 16 by 1, by 2, by 3.
48.
48, good. And then sometimes it's good to put that reference up here at the top. See how they're the same?
Yeah.
So you write your new denominator on the bottom. All right, so now 16 times what number? How do we go from this 16 to 48?
I divided by 3.
Multiplied by 3.
Multiplied by 3. Oh, yeah.
So how do you go from, what are you going to do to the 15 on top?
Multiply it by 3.
Okay, what is 15 times 3?
15 times 3 is 45.
Okay. Now let's look at the other side or other set of numbers. 12. How do you go from 12 to 48?
12 to 48. I
What do you
multiply
multiply
4.
by 4? What will you multiply the 5 by?
4.
Okay. 5 times 4 is 20. So tell me what the result is when you subtract 45 minus 20.
15 over 48.
25 over 48.
Oh, 25. Okay.
All right, so here's a new problem for us to look at. So notice if we were to find the least common multiple between 4 and 25, we have to write a lot of numbers on the top just to get up to 25. Do you see that?
Yeah.
Okay, so sometimes when it's a lot to write, you just go back to multiplying by 25 or by that other number. And then similarly, you take this 4 and you multiply these numbers by 4. So we're going to do it that way because it's a little bit easier. What is 3 times 25?
Times 25.
3 times 25, 3/4.
Times 25. 25. Is it 65?
75.
Oh, 75. Oops.
And 4 times 25 is 100. Okay, how about 8 times 4?
8 times 4 is 32.
And 25 times 4 is 100. Right. Okay, so what is 30? What is 75 minus 32?
75 minus 32. 43.
43. Good. Very good. Let's see if the next one is fast or not. Yeah, so this is enough to get you through 3.10, 3.10. It looks like you're a few lessons behind in terms of just getting kind of
Yeah.
all caught up. But if you got some time, I mean, go in there and you can enter some of these answers. But that is it for us.
Yeah.
Zoe, for today, you can let Michael know that I'm ready for him.
Okay.
And we'll see you next week.
Okay. Thank you.
You're welcome.
Hi.
Hey, Michael, how are you today? It's great to hear. You doing anything fun this weekend?
I don't think so.
All right, well, maybe that'll change. You still got a day to figure that out tomorrow, Friday. How's math class going?
Good.
All right, well, we're gonna do more fraction stuff today. Basically, we're gonna work on the manipulation of the top and the bottom here. So do you see in this problem here how 8, 16, 6, and 20 are the bottoms?
Yeah.
Okay, so we're gonna start with 1/4. And let's say we want to go to an 8, okay, on the bottom. So what would we multiply 4 by to get 8?
2.
2. So 1 times 2 up top is 2 over 8. Do you see how that one is 2 over 8 there?
Yeah.
All right, now we're going to do it for the next bottom, which is 16. 16 here. How do you go from 4 to 16? What do you multiply 4 by to get to 16?
4.
Okay, and then so you're going to multiply the top number by 4. See how there's 4 over 16 there?
Yeah.
Okay, now can you go from 4 to 6?
No.
No, you cannot. So that one's out. Now, last one is, can you go to 20? Can you go to 20?
Yeah. 5.
By 5. So this becomes 5 over 20. That one there. Any questions on that?
No.
Okay. All right, so this is again, these are probably just review questions. If the bottoms are the same when you're adding the fractions, and you'll see that here. Snip this in. If the bottom numbers are the same, do you see how the 12 is the same on the top and the bottom?
Yeah.
How do you add the fractions in this case?
At the top.
Okay, so that's 9 over 12, but that answer is not anywhere in this list. Can you simplify this fraction? Is there a number that goes into both the top and the bottom?
Yeah.
Okay, what number divides both 9 and 12?
3.
3, yeah. What is 9 divided by 3?
3.
Okay, and 12 divided by 3?
6.
Try again.
Oh, 5.
Try again.
4.
4, yeah. Is that number there in this answer space?
Yeah, all the way on the bottom.
You got it. Yeah, nice. All right, let's see what's next here. All right, so a couple of quick questions for you. Do you know what a decade is?
No.
So a decade is 10 years. Have you heard of that before?
No.
Okay. Have you heard of a century?
I heard it, but don't know what it is.
It is 100 years. Okay. So a decade is 10 years. A century is 100 years. So sometimes you'll hear people talk about the 80s or the 90s, and they're talking about a decade. Is that okay?
Kind of confusing.
They're just words to, instead of saying how many days, well, for example, a week is 7 days, right?
Yeah.
So if I ask you when your birthday is, you don't tell me that it's like 84 days away. You might say it's, a couple weeks away or a couple months away. And so the idea is that we can use these words to represent bigger numbers rather than using the smaller numbers. Let's see if we can find a new problem here to look at. Yeah, okay. So it says which fraction is equivalent to 9/10. So notice that all of them have 100 on the bottom. How do you go from 10 to 100? What do you multiply by? What do you multiply by?
10.
Times 10. So what are you going to multiply the top number by?
5.
10 also. What is 9 times 10?
90.
Which of these matches that answer?
See the third one.
Yeah. All right, very good. It is C. Okay, so here's a new problem for us to look at together. Okay, let's say you want to put 100 down here. What would go into the top?
10.
Well, you're multiplying by 10, right? So you're going to multiply this top number by 10.
Okay.
So tell me the result of that, please.
$50/100.
Very good. Very good. Right. Okay, so a few more problems here. We've been doing this a bunch, but we'll some new things here. Okay, so we're going to add 4/10 and 23/100. So 4/10 plus 23/100. So can you go from the smaller to the larger?
Yeah.
What do you multiply by to go from the smaller to the larger?
Uh, 7.
You multiply 10 by 7 to get to 100?
Oh, I thought you were talking about 4. No, 10.
By 10. So you multiply by 10. So you're going to multiply both the numbers on the left by 10.
Okay.
So what 40 over
100. 40/100.
Okay, so now I want you to add up the fractions.
Okay.
Forty plus 23.
Oh. 83.
Try again.
$53.
Okay, let's do this together. 0 plus 3 is 3. What is 4 plus 2?
8.
You're adding, Michael, adding
Oh, 6.
6. Okay. All right, so let's try another problem here. Let's say we want to add 3/10 plus 48 over 100ths. Okay. Just like the previous problem, can you go from 10 to 100? Can you go from 10 to 100?
Yeah, by multiplying them.
Okay, so we're going to multiply both the numbers on the left by 10.
Okay. Oh, 30 over 100 plus 40.
48 over 100, good.
The 8 over 100.
Try again. Add up the numbers vertically.
58 over 100.
Michael, you're 3 plus 4. 3 plus 4. Okay. 3 plus 4. You're just adding vertically.
7.
The 78. Okay, let's try another one here. Let's go 4 over 10 plus 60. Let me change it. Let's go 57 out of 100. Okay. Why don't you try this one on your own, please?
Okay.
How are you doing on this one, Michael?
I already finished the problem.
What is your answer?
97 over 100.
Really good. It's really good. Whenever you're done, let me know. I'm just being quiet because I don't want to interrupt you while you're working here. So here is another problem for us to look at. So you're going to add up the fractions just like we've been doing. So I want you to add those two fractions and then tell me your result when you're done.
Okay.
Do you have an answer for me?
Yeah.
Okay, what is it? Don't worry about that it's not here. That's why I'm asking you for your answer.
I was almost done.
Okay, let me know when you're done.
Okay. Six over 100.
62 over 100. Does that sound right to you?
Yeah.
Okay. Now, can you divide both of these by 2? They are both even. So you can.
Yeah.
All right. Now, 100 divided by 2 is 50. Okay. What is 32 divided by 2? Can you figure that out for us?
Oh, okay.
And if you're not sure, you go back over here and you write 2 on the outside, 62 on the inside.
Okay.
How many times does 2 go into 6?
3.
3. How many times does 2 go into 1? Or 2 go into 2?
1 time.
Yep. So the answer is 31 out of 50. Any questions for me on that, Michael?
No.
Okay, well, we're going to stop here for today.